video in this module 2 of our playlist in psychological statistics. Um, right after determining what a sample is or what sampling is, we need to also determine what our sample size, our appropriate sample size will be. So talking about sizes, it's not really the literal size. When you say size, it's talking about the number of participants or subjects of the study we need in a certain sample. So when you say population size, it's the total number of your population. When you say sample size, it's a total number of participants or subjects in your study. So how do we determine our sample size? The um, common traditional way of determining the sample size is making use of the Slovin's formula, but it was discovered, or rather, it was researched that it is not actually a catch-all formula for sample sizes. Actually, there's a paper published in the Philippine Statistician by Tejada. Sorry if I forgot the name. Way back 2012. The title is On the Misuse of Slovin's Formula. You can search that. You can Google that right now. Okay, the title is On the Misuse of Slovin's Formula. In that paper, it was discovered that actually there's no one named Slovin to start off, who discovered the formula. The first reference regarding this Slovin's formula was actually Yamane, a book of Yamane way back in 1960s, 70s, so something. But the thing is, there's no one named Slovin to where the formula came from. So you can Google it on the misuse of Slovin's formula. So therefore, what we're gonna teach you here are the things that we have agreed upon in the department on how to properly determine the sample size in a social science research. So before determining the sample size, one needs to ask themselves first this very important question. Do I have the information about the population? Specifically, what information do I mean here? Um, can I obtain the population size? What I meant is, do I have the population size of my population? Okay, so that's the very thing that you need to do first. So can I obtain the population size? Can I know the total number of participants that I have in this kind of study that I have? So, well, pretty much it's a yes/no question. So we can answer it via yes and no. The answer, if the answer is yes in your particular study, therefore, what we will use is the Cochrane's formula in determining your sample size. It's called Cochrane's formula because it is discovered by, or it was formulated by William G. Cochrane. This was one way to determine the sample size, given that you can produce your population size. Okay, so I'm going to show to you that later, that we don't really need to manually do the Cochrane's formula. Just as long as you have the population size, we can just Google calculators online and then we can produce the sample size. But if the answer is no, that it cannot be determined, or you have some trouble, ethical issues where you cannot get the population size, so therefore, no need to feel bad about it. We can always make use of what we call power analysis in order for you to determine your minimum sample size. Okay, we're gonna make use of the software application G-Star Power to answer that. Okay, so first off, let's go and see Cochrane's formula. So again, we're not gonna make use of, sorry, we're not gonna make use of the traditional way or manually computing the formula. We're gonna by default, because that's the way it works. I won't do anything because that's the default in sciences. In social science research, these parameters are always acceptable. So as you can see, I don't have any blanks for the population size. Just check this small population and let's try to change the population here. Now, say for example, your population, everyone, that this is the minimum. You can always go to the minimum. The rule is, it's okay for you to always gather more than the minimum sample size, but it's never okay to, gather less than the minimum sample size. As much as possible, we need to gather more than the minimum. So This is the calculator Cochrane's. Again, you can just search it in Google, then it will give you this. If you know your population size. Now, what if I don't, sir? Okay, so if you don't know your population size, you can always make use of power analysis, making use of this software, which we call G-Star Power. Now, you can freely download this. It is downloadable in Google. You can just download it. You can just search that in the search box. But please don't forget to cite them, as well as in RowSoft and in Qualtrics. Don't forget to cite them when you use them, please. So, for G-Star Power, since you don't have any information for your population size, it will actually make use of power analysis. Power analysis is making use of the power. We call it the power. So, with this one, you don't have information about your population size, but you need to have an information about the statistical tool that you will use in the future. That's why in our previous formulas, it is quite pivotal for you to determine your or classify the type of research objective that you have. So, for example, if we have a type of objective that measures differences, we want to ask if there's a difference between, say for example, anxiety level between sex. We're gonna make use of the t-test of independent samples. First, you click on the t-test family, and then click on the statistical test. Since we're gonna make use of t-test and it's between sexes, we're gonna make use of difference between two independent means of two groups. So this will be our t-test of independent samples. Down here, we can see some input parameters. I want to measure the significant difference, so that's gonna be two-tailed. I will just let the others to be by default. The effect size will be zero point 0.5. The alpha will be 0.05, which is our significance level. And I'll change the power. The power would be 0.95 by default, but the acceptable based on literature is zero point 0.8. Just a tip, the lower your power, the lesser the sample size, but make sure that it's acceptable still. So zero point 0.8 or 80% is an acceptable power based on literature. So I leave that be, and I'll click calculate, which is down below. I cannot show that because I'm not sure. It doesn't fit the screen. It's quite in portrait mode. So I'll click calculate. But you can see here the results on the output parameters right here that you are given a total sample size, which is 128. So everyone, this is your minimum sample size. Just follow this. And if you're talking about, going back to our example problem, anxiety levels between sexes, we have group 1 and group 2, male, for example, 1, female is 2, for example. So you need to have 64 participants for males, 64 participants for females, and a total of 128 all in all. Okay, so take note, even though you don't have any information of your population, you can generate your populations or your sample size. You can generate your sample size making use of this software application G-Star Power. I am not sure if this is the latest, but hey, it works, yeah. Okay, so that's it for this video. I have taught you how to determine the sample size. If you have, number one, your population size. Number two, if you don't have your population size. Again, there are no barricades for you to determine your sample size. So it's okay if you know the population. Um, it's good if you have a sampling frame or the list of everyone in the sample, but it's also fine if you don't have any information of your population. And seldom there are cases wherein you cannot really determine the population size, even though how much you try, or by ethical considerations, you cannot get the total population. It's still okay. You can still determine your minimum sample size. Again, as a general rule, you can always go or gather more than that of the minimum sample size, but never less than the minimum sample size. It's called the minimum for some reason, right? So that's it for this video. We have determined how to determine the sample size, and see you in the next video after this. Thank you very much.